Alright, so we're going to try this again. Technological glitches. You know how it is. Alright, so where were we? We were multiplying this, what is that, a 1 by 3 matrix? 1 by 3 by a 3 by 1. We're going to end up with a 1 by 1. We're going to do our work there, and then we're going to clean it up and put our answer in a nice little 1 by 1 matrix. So what is this going to look like? Well, first element of row 1 by the first element of column 1. So that's going to become 7 times 2, so I'm going to put a 14 right there, plus, and then I'm going to go ahead and do the second member in the row by the second member in the column, 3 times 9, so 3 times 9 is 27, and I'm going to add to that let's see what's left. We have 2 times 5, and then I end up with 2 times 5, which is 10. Put that number right there. So 14, 27, and 10, 37, 47, 51. So my answer is a 1 by 1 matrix with 51 in there. Okay, we're almost done. Thank you for staying with me. So now here we have the same two matrices, but I'm switching the order. So instead of doing the 3 by 1, the 1 by 3 multiplied by the 3 by 1, I'm switching it around. So let's go ahead and perform this multiplication problem. First question should be, very good. Can we even do this? This is 3 rows by 1 column. This is 1 row by 3 columns. So when I look to see if this is even possible, yes, it is possible. And we're going to end up with a 3 by 3 matrix when all is said and done. So 3 by 3 matrix, row 1, column 1, row 1, column 2, row 1, column 3, similar, 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 row 3. Alright, so there's where I'm going to put my answers. Let's see how this looks. In order to get first row, first column, I'm going to multiply row 1 by column 1. So row 1 by column 1. So 2 times 7, I put my answer there as 14. If I want to know what row 1 column 2 is, row 1 column 2, I'm going to do row 1 by column 2. Put my answer there as a 6. And let's see, row 1 column 3, I'm going to do row 1 by column 3, and that becomes a 4. And ultimately you can find out any spot you want. Like for example, this right here is row 3 column 2. That's the element A sub 32, row 3 column 2. If I want to find out what number goes in that spot specifically, well, row 3 column 2, in order for me to get that, I'm going to multiply row 3 by column 2. The first element of the row by the first element of that column. Turns out there's only one. So I get 5 times 3, and that spot is 15. Do me a favor, fill in these 5 remaining spaces and check back with me in a few minutes. Put me on pause. So I'm hoping I gave you enough time to put that on pause before these answers just popped up. But here they are. 63, 27, 18, 9 times each of those numbers, and so on and so forth. So if you have any questions, you can let me know about that tomorrow in class. And here is our last page of notes. Here I have matrix A, here I have matrix B, and I'm asking you to find A plus B, B plus A times B, and B times A. So let's first start with attacking the addition ones. Well, before we can do any of this, before we can do any adding or multiplying of matrices, we need to identify the dimensions of each matrix just to see if it's even possible to perform these calculations. So let's do that first. Matrix A has how many rows and how many columns? Matrix B has how many rows and how many columns? Okay, so if I want to add matrices, what must be true about the dimensions of the matrices that I'm trying to add? Very good. Since I need the matrices to have exactly the same dimensions for addition or subtraction, and these matrices do not have exactly the same dimensions, these addition problems are not possible. Not possible. Not possible. However, the multiplication, we can see right now that it is possible to do matrix A times matrix B. Matrix A has 3 columns. Matrix B has 3 rows. So I can perform this matrix multiplication. How big will my resulting matrix be? It should be a 2-row by 3-column matrix. 2-row, 3-column matrix. Give myself some space to do my work. And just to get you off on the right foot, and then you're going to finish the problem, I would first like to find what goes in row 2, column 1, A sub 2, 1, row 2, column 1. What goes in row 2, column 1? Well, in order to do that, I'm going to take row 2, which is right here, and multiply it by column 1. And what does this give me? 1 times negative 2. Alright, so what does row 2, column 1 get for me? 1 times negative 2 is negative 2 plus 0 times 1 is 0 plus 4 times 0 is 0. Well, that's nice. So then I end up with, in that spot right there, that's too far. Come on now. Oh, arrow. I end up with my answer being a 2 by 3 matrix, and down here I know that this is going to be negative 2. See if you can do the rest of these 5 elements for the product between matrix A and matrix B. Take a few minutes, give it a try, see how it looks. Okay, so hopefully this is what you ended up with by the time you finished multiplying these 2 matrices together. You can see all the work up here that kind of gives you the result and final answer down here for matrix A multiplied by matrix B. Let's take a look at reversing the order, matrix B times matrix A. And I think when we look at this, we'll find out this is going to be the type of problem you like, because it's not possible. Matrix B has dimensions of 3 by 3. Matrix A has dimensions of 2 by 3. And since when I look at these 2 inside coordinates here, they're not the same, we can determine then that this multiplication is not possible. So we talked the other day, or in the other lesson, about addition being commutative, but matrix multiplication is not commutative. Multiplication is not commutative. Alright, so if you want to perform the multiplication forward and backwards, you actually have to do it both ways. Alright, well, I hope that was helpful, and I'll go ahead and check those notes into class tomorrow, or actually on Tuesday, whenever you are doing this. It might be tomorrow for some of you. Alright, let's just double check. And you know, I thought it might be a good idea if I actually give you the actual assignment at the end of this, in case you want to get started on it. But do give yourself time in class to work on this as well, so I can answer some questions then. And notice that on Wednesday there's a good chance we're going to be having a quiz. Alright, I'll see you guys on the flip side.